Okay, you'll find this funny, my students. By the way, good day. I hope things are going well. Hopefully you're not getting sick. I got an email saying the governor has extended this through past Easter. The Monday past Easter now is the first time we'll come back. So that's another 3 days because you have the Thursday and Friday already off because it's Holy Thursday and Friday. But that's okay. We're having so much fun with this. I bet you're playing together with your brothers and sisters and life is good. But anyways, I kept trying to clean things because this was so foggy before. And here I cleaned everything but the camera. So, we all learn. Anyways, so there's really only one reason to use logs. Well, there's formulas you'll need, but is when the power is unknown. So here you just take the log of both sides. Yoo-hoo. Look how pretty that is. Bring the power out. That's the third law of logarithm. Then divide by log is 6. Now, the one mistake people tend to make is they'll go 12 divided by 6 is 2, and you can't do that because you have a mathematical operation in front. But if you have a cheap calculator, cheap, you go 12 log divided by 6 log equals, and I get 1.386 blah blah blah. So we'll say 1.387. So really, if you know what you're doing, you could just say x equals log of 70 divided by log of 4, right? Because you go log of 4 to the x equals log of 70. So x log of 4 equals log of 70. So divide by log of 4, log of 70 divided by log of 4. Now, if you're doing this on the decimos, which I normally would be doing it, but I can't do decimos when I'm making a video. So, you would just go log of 70, but you have to be careful that it automatically puts a parenthesis here. So you have to use the arrow button to push it past this parenthesis so it knows it's log of 70 divided by log of 4 and not 70 divided by log of 4, take the log of. So you got to be careful. So I get, see, this is so shiny you can't see it. And that irritates me, but that's okay. Now, you can approximate this. We know that 4 to the third power is 64. So we know it's going to be a little bit bigger than 3. So this one, it'd be log 3 to the 2x equals log 4 to thou. So it'd be 2x. I'm going to do 2 steps here, by the way. So we're going to do 40,000 log divided by 3 log equals, and then divided by 2. Now notice I get 4.8 blah blah blah. Oops. Notice how that's so small. That's why working with logs was so much better because we got the base of 40,000 or a number of 40,000, base is 3. Then, but you're still just working with 4.822 as an answer. So very tiny. Now, again, you can remember the change of base formula, which is it's just log new base of what you were taking of divided by log of the old base. But I think it's silly to remember that. That's why I didn't even show you. Set it equal to x, rewrite it as an exponential, then take the log of both sides. So you could just remember, which most people forget, log new base, which is 10 of 90, divided by log of the old base. But again, if you just set it equal to x, change it to the exponent, you don't have to remember anything. Take the log of both sides and solve. So let's see. It's 8 log divided by 5 log equals, so 1.29. I like when you round to the hundredths myself, but 90 log divided by 3 log. So again, I'm using an old calculator. So, but if you're using the Audacimos, you would just go log 90 divided by log of 3. Then we have, again, set it equal to x. 4 to the x equals 60 thou. So log of both sides. So x, I'm going to skip a step, log of 60 thou, divided by log of 4. So 60 log divided by 4 log equals, and I get 7.94. Okay, I'm gonna make another video on a formula that's pretty important. So, okie doke, have fun.